Dear Dr. Holger Kuhnlein, who is the Senior Vice President Technology and Innovation of RENA, a long-term and leading supplier of wet chemical solutions. And Holger will talk today about the latest development regarding P-type solar cells. Holger, the floor is yours.
Thank you, Michael. I think you can hear me. We tested before perfectly. Now we're sharing screens. One moment. Do you see my screen running?
All good.
All good. Perfect. So thank you for the introduction, Michael. It's my pleasure today to talk about pushing PERC cells to its limits out of the perspective of a wet chemical supplier. And of course, as already mentioned by the colleagues before, Joris, Shravan, great talks. I will focus on texture and chemical edge isolation, and finally, I will give an outlook what can be done in wet chemical metallization. Before, a very brief company introduction. I think the ones of you not knowing RENA, we founded in 1993 with our global headquarters in the Black Forest in Germany. We're located in Gütenbach. Overall, we are 1,200 employees and serving worldwide. The installed current machine number is about 3,000 pieces, and this is how we support our customers as a reliable supplier. Coming to an initial slide, I would like to share with you, which is about PERC in transition, I called it, and for me and for RENA, it means actually a long period. Coming out of aluminum BSF, as Joris said, the transfer to PERC was for us, let's say, evolutionary ones. We adopted the wet chemical processes, and we are achieving in the last year, at the end of the last year, at leading suppliers above 23.2% with PERC. And most in this cell technology right now is fixed on cost reduction and throughput increase, which was said before already. And in parallel, we all see how the new cell technologies ramp up. And this is something we consider now at the moment as a heat zone, because surprisingly for us, the race goes on with adaptations of polishing, texturing, metallization, and material that we're reaching above 23.5%, and we're seeing the cost figures, especially in the wet chemistry, going down and down. Not only the tools, but also the consumables. And right now, we're seeing in parallel heterojunctions, IBCs ramping up, and also TOPCon. And for our opinion, they will need these very high and latest published efficiencies, 25%, 26%, high above 24% for TOPCon. To really get out of this heat zone and complete the transfer from PERC to the next cell technologies. As said in my introduction, for RENA, the important step is, of course, at the beginning of the line, the texture. And here I would like to share with you our working horse, the N600 platform, where 6 carriers placed in. Normally, these carriers contain 100 wafers. But as already mentioned by Shravan, extensions are going on in terms of the length of the carriers and the tank design. And so even plus 20% of the throughputs I mentioned here for the specific wafer sizes can be reached. But this is actually not what I want to talk about. I think the main focus is on the texturing process itself and how it distinguishes and what can go on in PERC and what is the differentiation to the new cell concepts. So starting from a very generic point, we have to say the customer's motivation is, of course, at the moment, the low-cost texturing for PERC consists that there is no saw damage removal before texturing, and then there's extremely low chemical consumption, so the edge depth is at its optimum, and the reflection and the additive baths created here are interact with the process where you don't do any saw damage removal. For sure, there is a pre-clean and conditioning of the before the wafers enter into the texturing bath, but all that has to be stable over bath lifetimes and optimum for VOCs. So this is main motivation of our customers. If we're talking in KPIs, this means reflections below 9% are favored. Long time, the pyramid size was drilled down, and we're reaching in some approaches and seen in the field 1 micron plus minus 0.5 micron differentiation or distribution. And this is something very considerable, discussed forward and backward, but I will comment on where actually the way goes at the moment. And this has to be integrated, especially with best passivation form performances of the follow-up processes. And it's extremely critical and differentiates a lot these texturing processes from what we can use and apply for heterojunction and also for TOPCon. So looking on the middle and seeing these typical pictures, I try to show some SEM pictures where you see the standard pyramid in a perfect shape. And if you look on the upper picture, you see that peak or pyramid angle tailoring is something, the keyword, which was ongoing in between all the additive suppliers in texturing. And this enabled what we seen in reflections coming down from these approximately 10% reflection in 2020. And with these new additives and recipes in combination with no saw damage removal, it was driven down actually to 9%. It can be even done further. We did also some publishing that 7.5% is achievable. On the other hand, stability and the integration, as the passivation has to work afterwards anyhow, I think everyone shares with me that point, it's necessary. So at the moment, astonishingly for me, the clock turns a little bit back in terms of pyramid sizes. We are seeing here 2 to 4 micron, quite wide range. But the parts of these angle tailoring, which were seen, in my opinion, in the past in the roadmap, more in the future, were integrated. And we're running here starting from 9%, and over the bath lifetime, we have a variation of 5%, which is actually great. For the future, it is hard to predict, honestly. I think the dream of every chemist and texturing company involved in here is to provide something like a next-gen texturing, which can call black silicon. But all the time we're creating nanostructures, which is also better and better understood. It turns back to the field, how to integrate it, how to bring good passivation on it. And this is something where we see that PERC is squeezing out the optimum. And we have a direction which is not integratable for heterojunction or IBCs especially. So the roads split it here. And in a simple flow, you see the road splitting. So saw damage removal or even cleaning before saw damage removal is highly relevant for heterojunction IBCs. And this is not done at all anymore in PERC. Texturing gets splitted in some cases in 2 baths and also 2 processes. It's so-called 2-step texturing, Not sure if this is a hype, but you can see here slightly lower reflections. And this is favored by some customers, by others not, because it's achieved with a single additive etching, standard etching of the wafers. And the cleaning, here is some focus on here and some impact there where elevated temperatures and right choose of acids can help even here to bring a tiny distribution. But as mentioned, things are squeezed out. We have here a state-of-the-art product which is good and compatible to heterojunction and IBC texturing. And as I mentioned, we call it here the H3.7 series. It has smaller pyramid sides. It has this ankle, pyramid ankle shaping already in there. And there we can achieve the 9%. And we're fighting with against the competitors to have these shift over the bath lifetime on a very low level. So it is desired to have this 0.5%. And this actually brings me to my summary in texturing, that we definitely see that there is hype with the two-step texturing ongoing. Not sure if it's a hype or if it's something which will be seen more often in the market. But all this, what I mentioned, is actually contributing on a very low level in efficiency, hardly to see even with good statistics. So, so for Perk, it's squeezed out in terms of cost, as I mentioned, and reflectivity is coming to a reasonable status at the moment and is more focusing on stability and on low consumption volumes of the additives. The second part in a wet processing line for us is the inline or the edge isolation in general, and I will focus on one product. Want to highlight it. It's the so-called inoxide fusion. And fusion is actually a process which combines acidic and alkaline edge isolation process. So the tool is extended in size by almost 50% to a standard acidic line. And it has the great advantage that you can extremely flexible adjust the rear surface shape. And there is a special clean in the first time, a really boosting inline clean sequence integrated, and there is more than 75 tools right now out in operations. And this tool line, as I mentioned, has acidic first part, where you do actually the edge isolation, and then you do with the alkaline step the polishing, and to achieve the best VOCs according to the passivation methods you're using. Okay, the concept is nice in terms of, because in comparison to cluster solutions, it does use ozone for cleaning. Never used and never will use any hydrogen peroxide, and also it's beneficial for in its cost of ownership, because it reduces at this moment the HNO3 content by up to 70%, and we achieved 0.1 and even higher efficiency gains with our installed base. So to giving you a little bit pictures, I decided to pick out on the left-hand side the texture as it looks like directly after the batch machine or even after the diffusion. And when we're coming to an acidic edge isolation, here you see how the surface morphology changes as deeper you etch. And to be honest, the roughness you're seeing here with 6 micron, which is really an edgy process, is still not in a level as it could be for a polishing process at its best. At its best, it's definitely to follow up with an alkaline process. And you see here that we can achieve flatness if we do these combined processes, where we in totally only etch 2 microns. And it's much better than if you do acidic or pure acidic etching with 5.5 microns. So this is what this fusion process does, a perfect rear side polishing. And as mentioned, in cell lines, some older data, but I think still relevant. We have been able to achieving in an early stage of production here, in comparison to a full acidic edge isolation in oxide from RENA, achieved here in this PERC production 23%, slightly above. And this combined process was already a little bit higher. And once we switched on the ozone cleaning, which were integrated in a special mode in this machine, and a lot of R&D work was coming into, we achieving these totally 0.1.2% efficiency gain in this production site. As I mentioned, I think the story in reducing HNO3 is not the full ones. Everyone is aware that driving down the cost, nitric acid is one important factor. To have it not in a facility helps, to have it not in the environment helps, and that's why we developed and working on an inoxide blue, which is the full inline alkaline approach. I think it's a same benefit, but it has 100% HNO3 processes in there. And in comparison to these batch clusters I already mentioned, it's the same like the fusion before. It's an all inline solution. So for the tool, which is right now out there, I think it's not something completely new. A lot of competitors tried hard in the past. We are followed late, but nevertheless, I think we're doing exactly. We know exactly what we're doing, and we started up end of last year this tool, and right now we are in the phase of achieving first results with these 2 hot alkaline single site edge baths to create a perfect polishing in our process. As mentioned before, here the highlights again, and of course you can imagine that beside the performance highlights and the all inline solution, also the cost of ownership is something considerable, because we ended up with 30%, 35% of the costs we had before with the pure HNO3 approach. I inserted to highlight our status. As we talked about efficiency achievable with PERC, so these are latest results from our startup phase. So we're seeing 23.3% ETA, which is quite a good for this early stage. We are currently optimizing the hardware and the processes itself, running the DOEs. Due to COVID, everything is slow and hardly, but we are confident to achieve this goal of 23.7% in this line. Jumping into the cost and cost comparison, I think it's important to highlight that when we coming from pure acidic processes, people were often looking extremely on the best value of reflection, but there is always an optimum. It's not about to etching more, and it's getting better. It's already things get saturated at a stage of 5 microns. But here I would like to show you and share with you some graph, how things appear in the market and how actually they contribute. So we tried to make a visualization where this old pure nitric acid process inline, the working horse for a long time in PERC, is like what RENA recommends with the recipe is the 100% cost of ownership. While we've seen, of course, in the market guys who's really trying to have the lowest chemical consumption, they were even able to reduce by 34% in comparison. But others, they were keen to run the best polishing and the highest edge depth. Sometimes mixing things up, to be honest. They, of course, could run this machine with a huge consumption over the recommended recipe. Taking the new machine concept in 2021 and inoxide 3 into account, and this recipe we're seeing here from the second column, we've been of course, able to drive down the cost of ownership. But interesting, it becomes here for the colorful right-hand side columns, where you see all these technology solutions achieving by a better polishing performance, 0.1% efficiency gain and higher. And you see here a cluster solution where you do glass removal followed up by a batch machine doing the polishing and the cleaning. And the cost comparison says definitely that the 35% a reduction or down to 35% of cost in comparison to these 100% above. The Inoxide Blue is the leading technology in this term of cost of ownership. Using the final 2 minutes I have is I want to give you a short impression on metallization. And I think it was already mentioned by Joris and others that, of course, metallization silver cost contributes a lot in PERC. There's great optimizations ongoing for sure, but the new cell concepts, especially TOPCon and heterojunction, will even consume more per watt peak than PERC today does, and this has to be followed up. And this is also what we as RENA are seeing, that again the plating topic, even if it's discussed since more than 15 years, it is considered again and again if it could be a key to bring down the cost. Looking on the process flows, I think Joris already did. I not really have to deep dive in here, but once you're doing a PERC cell standard and leaving out the front print, you're doing, instead of this front print, after the firing of the rear side, a lasering, the plating, and annealing, which is necessary. And this process has been optimized. So the laser ablation takes place where the laser ablation of the rear side passivation, so same station. Then you have the printing and the firing, with the advantage that there some curing happens, and this curing allows higher VOCs, because honestly, laser always does damage, and this damage can be cured mostly if you apply it before you do the rear side printing and the firing. And then you can follow up with the stack plating and RTP annealing, which is also an important step we did in the last years, where we not need any more nitrogen, because the annealing is such as fast and focused that this will help to bring down costs. Looking at some performances graphics we've done mainly on customer samples together with Fraunhofer, we've seen that this effect I mentioned, that the laser opening is done before the fast firing. We've been able to push these blue bottoms up, points up in voltage. And as we're following with the institutes and the partners where we right now have installed the plating tools, smaller and smaller opening areas, you can see that we, in this extrapolation, it is calculated and estimated that the voltage can improve in the region where we discussed before, around 690 millivolts. For the short circuit current, the same story goes along with the spot size of the opening. And so we believe there is a comparable or realistic comparable or even higher efficiencies with the laser optimization and the plating optimization process for PERC viable. And this leads me to my final slide in here. The cost of on the base of the current silver price, and it surprisingly does not move a lot during these chaotic times at the moment, but nevertheless it's quite attractive. As you can imagine, the main part, the consumable, is driven by the silver cost. This is driven down extremely, and overall you can face 48% of savings in comparison to printing lines today, but of course with the hurdle of a considerable capex now. So this brings me to my summary and to my last slide in this pushing PERCs to this limit session. I think, as mentioned, in the texture, the things are squeezed out. Reflections below 9% are viable. Stability and consumption is driving here the story to more effectiveness. The inoxide fusion and the inoxide blue is the story to become full inline without additional handling, so all inline and without any nitric acid. And we seeing, and at the moment, the efficiency is above 23.3%, and we hope to drive it even higher at this extremely low cost of ownerships. The plating, as said, 600 millivolt is the area where we have to be, where we have to reduce the spot sizes. And so a reduction in metallization would be addressable. And this could help PERC even further and make it more competitive in the future if somebody invests still in here. So my team and Damien supported me a lot, and we discussed about the last headline, challenges and interactions in 2024. So for us, the challenges is definitely in the market and seeing now TOPCon is taking over as the main expansion technology, but it has to go well above 24%. Even 25 is something we see is needed in our opinion, as the process is more complex and the cost is even higher. For the team ourselves to introduce these technologies with our colleagues in China and worldwide, of course, are these COVID restrictions, and to foresee or make a forecast in a roadmap, all these turbulences we've seen in the energy, politic, and financial world is really difficult. And I think, yeah, it still will be exciting in the next months and years what turns out here. In technology-wise in PERCs and for the new cell technologies coming up. Thank you for your attention.
Thanks, Holger, for this great overview. I think you showed this great matrix. Maybe one question from mine, even for a bit late. And you said TOPCon has obviously the challenge to get to higher efficiencies because it is somewhat more expensive and more complex. And we're seeing now actually and there are some rumors discussing actually, or that some players actually might now try to go to PERC Plus or TOPCon P-type. Can you maybe actually comment on that from what you are seeing?
What we definitely see is, to our surprising, that going away from PERC, we believed it will be a very mainstream on TOPCon. But now, as you mentioned, there is IBC, even on P-type polo cells is something, rumors, to be honest, and nothing really I can share in here. And additionally, of course, PERC Plus is something I not really see. It's something that the PERC lines, we see that they run with full alkaline edge isolation and optimizing the textures, but there's no plus I can really see in a technology stepwise. But maybe later on the colleagues can share, and maybe they can disclose something. But for me, that's the picture in the world. And for
RENA.
Okay,
super. Thanks for that great insights. Okay.